All right, and we're back. Hi, everyone. We're going to go ahead and get started in a few minutes here. I'll do some introductions. So if you're wrapping things up and getting settled in, you'll have a few minutes before the demonstration. So just wanted to thank everyone for being here. My name is Nate. I'm on the partner engineering team at Sigma, and this is the very first Sigma partner webinar where we'll be learning how to unlock machine learning using Sigma on Snowpark. I know a lot of you have asked about this topic, so I'm really excited to share what we've been working on for this. All right, so I'm going to introduce our guest today. First up, we have Shawn Namdar. Shawn is the Partner Engineering Snowflake Technical Alliance Manager here at Sigma. He is all things Snowflake on our team, and he's a former application developer, a BI platform architect, and a Seattle Mariners fanatic. He'll be kicking us off here, and presenting with him is Fran Britschgi, a strategic solutions engineer here at Sigma. He's a SAS alum. He has a background in statistical consulting and data science. And at Sigma, he is currently leading efforts to show how data science can solve previously unsolvable problems for line of business data analysts using Sigma. So we're happy to have them both. They're going to show us Snowpark on Sigma. And with that said, let's dive in. Take it away, Shawn.
Thank you, Nate. Hi, everyone. Like Nate said, we're here to talk about Sigma and Snowpark and our path forward and our solution that we are excited to share with you. But first, let's do a little bit of level setting. So why are we doing this integration, and what's the purpose that we're going to be driving for our end customers? At the end of the day, we're excited about data science because the industry's moving. The winds are changing, and you can see it from thought leaders across the space. I've got a quote up in the top right of this slide from Sunny Betty, who is the CIO for Snowflake, calling out that BI teams are going to become data scientists long term, and data science is going to permeate every department in an organization. So Sigma has already established itself at bridging the gap between data teams and the business users. So we want to take that one step further and unlock all components of the data cloud, specifically in the data science space, to the business as well. So bringing Snowpark to Sigma, what we're really doing is we're providing the ability to have real-time data scoring, flexible scaling, consolidated analytics, all of the great things that Sigma can do, except specifically for data science use cases as well. And the goal here is providing a much more familiar interface for a business user and abstracting away all of the complexities of data science so that they're able to leverage the components of a model to profile their data just as easily as they would, but through basic Sigma interactions. And so what it results in is data science teams confidently and securely being able to share their ML models with the business in a friendly way that's not going to actually create more friction and therefore drive better ROI for our business's data science investments. So the solution that Fran will be walking you through, well, one of the solutions is a product feature that we're going to be launching that's going to allow for the ability for a Snowpark model that has been created and trained inside of Snowflake and then registered as a Python UDF to then be called inside of Sigma in a workbook in real time. So just as you would be able to call, sum or average or any of our normal Excel style functions, you'll be able to, with our new product launch, be able to call ML models the same way. So this is going to make it much easier. Today in the demo, Fran will be showing a proof of concept around that, and then coming in the future or in the months ahead, we will have an actual product launch around it. So without further ado, I'd love to hand it off to Fran. He'll go through and show us some really cool stuff around data science in Sigma.
Awesome. Thanks a lot, Shawn. Hopefully I'm coming through, seeing my audio there. So I'm going to go ahead and exit out of this presentation. One of the fun things about Sigma is the ability to actually embed the Google Suite inside. So we're actually in the workbook that I'll be demoing from today. As Shawn mentioned, and as Nate introduced, I'm really excited about the ability to take advanced functionality from the data science world and put that in the hands of business users in the form of Excel functions. So what we'll be looking at is an example where a loyalty model for new customers has been built by a data science team but the ability to assess new customers is a Excel-like function that business users can use to investigate what-if scenarios, explore how the model performs across their customer base, and experiment with hypothetical customers as well. So I'll hop over to the model overview tab. We'll get an example of what that looks like. So in our apply model table here, what we can see is some customers, some zip codes, some customer ages, and on the right is the predicted loyalty membership. And actually, before I click into anything, this is very similar to how business intelligence teams interface with data science teams. They get some kind of flat table that tells them the output, the model has been scored, it's ready for them to explore, but it's a very static interaction where the business intelligence team has to wait for new flat files, maybe at the start of the week, and it's just kind of a back and forth process. And while that may be what this appears like, just from its table view, when we select this predicted loyalty membership column, we see that we're calling a Snowpark UDF that runs against the customer loyalty model full. And this is the key difference here, is that we're actually able to pass new data into the model and get live output in terms of whether or not that member was accepted into the loyalty program. And just to demonstrate that in the most playful way, what we can do is on the customer age, I can just go ahead and double everyone's age and see how our model would treat a hyper-aged population. So we'll see that the customer age gets doubled, and that data gets sent back to the model behind the scenes, and we get a brand new output of predicted loyalty membership. So we're seeing our graphics calculate, and then we'll be able to see the table output as well to see exactly who and who isn't being approved. So while this query is calculating, what's actually happening as everywhere else in Sigma is that we're actually sending a Snowflake query back to the Snowflake warehouse, and then we're displaying the results here. So we can see the falses for all our 110 folks. This 122-year-old was actually approved for the model, so it must be coming from a good zip code. But we're able to see an example of what it actually looks like to allow a business user to apply this model on the fly. One other iteration of this is in the Score New Customers tab. So I'll open this up here. And what this stands in as is a way to leverage a new Sigma functionality called the input table, where users can actually input data just like they would in an Excel table. So this allows them to put in a 36-year-old from 08610 and see the direct output of that person in the model. So we can see that 36-year-old in 08610 was not approved. But if we wanted to say, all right, well, what if they were actually 56? We'd be able to send that new data back to the warehouse as well. So we see the query rerunning. We're going to adjust the batch that's being sent, and we'll see that 56-year-old reflected here. And the 56-year-old was accepted. And so this is that kind of what-if analysis on the fly that allows our team on the business user side to leverage the work that's being done on the data science team side. So tons of applications of this. We're combining that with some of the other things that you probably love about Sigma, which is the ability to make aggregate statistics on the fly. So I could calculate what's the approval rate of my new customers. I could do a calculation of all US zip codes that my new batch represents. And then in my zip code view here, I can actually zoom in and see how folks are being represented in a graph. So in my map, looks like a lot of the folks that I put in are in New Jersey, and I can actually see that 08610, that 56-year-old who was just approved. So tons of ways to actually explore the data here. I'll take a pause here and just check the chat and see if we're getting any responses or any questions about this. But hopefully this is explaining the end result of what can happen when we're applying a model that's been built in the data science team and then deployed for the BI team. Go back to this model overview here.
Yeah, it looks like we had a question about using input tables to pass parameters, and just wanted you to follow up on that.
Yeah, so the input table is incredibly flexible. Basically, it's just serving as a blank cell field where Sigma will create a managed table in your Snowflake warehouse, and then that table can be used alongside all of the other data or UDFs that exist in your Snowflake environment as well. So basically what we're allowing here is for customers to input brand new data on the fly and then leverage that data in alongside existing assets. So for example, in our model output, we're taking in the new inputs from the scored new data on governed models input table, and then we're able to put those inputs through that exact same loyalty model that I talked about on the previous tab.
Wonderful. Are there any other questions about this portion of the demo before Fran moves on? All right.
Great. So other applications of this, there's two tabs that I'd like to walk us through. These are just further exploring what folks can do in a Sigma environment once they have access to a UDF like this. One of which is model profiling. And this is the ability to explore model output on the fly using some of the Sigma visuals that we support directly out of the box. So on the left, I have a model profiler where we're able to see the age of account or the age of the customer and the zip code on the x-axis and see where the approval did or didn't happen. So in gray, we see where folks were not approved. In blue, we see where folks were approved, and we can start to get a sense of the shape of our model. It's a decision tree that's actually running on the back end, and we're being able to see the cut points that decision tree made. Like this whole segment here was not approved. This whole segment was not approved. What we can also see on the right is a way to kind of aggregate this. So the left is a more detailed view to see a full model exploration. But what we often see is from maybe executive stakeholders, a way to simplify the model and actually explain how it's acting in simple terms. So we're holding the zip code variable average, and we're assessing how on aggregate the age of the customer impacts the likelihood of approval. And we're able to answer that kind of real question with, all right, as your age increases, the probability of being accepted decreases. Some model bias techniques are also shown below. It's going to be a critical step in reviewing a model to see if key sensitive variables are being kind of treated sensitively. So for example, I mentioned that our model only includes age and zip code, but we do have information about the gender of our customers, and it's an important check to be able to see if there is a distinction between female and male outputs on the model. So what we can do with that kind of notion is build bar charts to see what the differences of likelihood percentages are, and then, as I mentioned earlier, provide key summary statistics to see if there's a delta in the percentage or a relative difference. And it seems to be that 35.08% versus 35.23% is maybe what we would accept within our model parameters. Furthermore, another Sigma value prop is the ability to join data assets on the fly. So what I can do with that predicted loyalty variable that I've calculated for all the customers in my retail space is I can actually join that against my 4.5 million rows of POS data. So I can see what's the loyalty statistics across my entire point of sale variables. So for example, maybe I want to start looking at the different stores and see if there's different stores that have a higher likelihood or a lower likelihood of having loyalty members. And so that's exactly what I do here. I bring in that predicted loyalty just using a simple lookup, and then I visualize this chart here to make a loyalty figures by store. And this is going to give me a nice graph that allows me to explore the differences here of predicted loyalty by each one of my stores. And what I can do as well is when I click one of these, it's actually going to pass a parameter to my product family breakdown. And this is a graph of the average purchase amount by product family. And while we're going through this, it's important to note that this is all sample data. But one of the things I love about exploring sample data is there's sometimes patterns in random noise that are really fun. And for example, in this example, when I select that top loyalty store of the Meadow store, we see that the average spend on the party and celebration is so much higher than the aggregate. So I can deselect out of that. The average spend on party and celebration for my populations is under 2,000. But when I look at just that one store, it's almost 3,000. And so it's just this fun kind of side effect of random noise where I can identify that maybe the folks who are buying all this party equipment are more likely to show up to a store. And even though that's just like a fun effect of randomness, this is exactly the kind of insight that a BI practitioner would be able to explore this way and start to say, all right, I'm understanding now how my model works, but are there other variables in my retail data and really in my Snowflake data warehouse as a whole that I can identify to drive up my key metric, which is getting folks into the loyalty program so they come back and they spend more and more. So that's an example of being able to identify that kind of key distinction. I'll take a pause there before I kind of hop into the second applications of UDFs. So maybe Nate, you can let me know if there's been any questions on this, and I can speak to those now.
Yeah, Fran, I think there's a more general question about training models you might want to hold off on and answer later about best practices there. But other than that, there's no other questions.
Okay, awesome. Yeah, I'll make sure to get back to that of how we actually create that loyalty model that we're able to send data into. That'll be my step after walking through the second UDF functionality. So I'll make sure to get back to that. So this next application here, it kind of flows naturally from this last conversation where I've identified that my metal store has this much higher spend of party and celebration. And I want to see if that's just a coincidence or if there's actually a relationship between those two variables being the average amount that you spend on party supplies and the percentage of loyalty members that you have going to your store. And that's a great question for Sigma. As I scroll down here, I actually have this party spend exploration table. And what I've done is I've grouped my data at the store name. I've grabbed their average of revenue from the same tables that I was using to make the visuals, and I've grabbed the average of predicted loyalty as well. So it's the same statistics, it's the same variables. And now what I want to do is give my business users the ability to actually fit linear models or really any kind of models to that data themselves. And so we're leaving the realm of the governed model, which was that loyalty model that we basically just wanted outputs of. And now we're moving to the ad hoc world. And this is where our end users can fit data or fit models in an ad hoc way and explore this kind of business question of, is there a relationship between the average revenue on the x-axis and the prediction on the y-axis? And in orange, we can actually see the linear fit that we built in our prediction above. And so what we're doing is we're calling a linear model extended, and this is fitting a model on the fly to the variables in my average of revenue column and my average of predicted loyalty, and it's fitting a first order model so that my business user can say, yeah, there does seem to be a positive trend between these two variables. The R-squared score, with some training, they'll understand that this is a good measure of fit. The R-squared score is not very high, so maybe this isn't something I should bet on, but there does seem to be some kind of positive trend between these two variables. And this is just one example of a UDF that you could expose, this linear model extended. What I have done when I define this is given a prediction output, I've given a score output, and I've also made it dynamic so that folks can actually fit different order models as well. So I'll change my model order to be 2 and see if a quadratic fit is actually more appropriate. And when I set fit to quadratic, now I can see that there's a little bit less of a pattern than the linear fit proposed. So this is how I'm kind of introducing us to the concept of ad hoc models. But a key distinction here is that there's no governance, right? The business user is able to apply models on the fly. And so the drawback of that is they may make bad models. But the upshot, the good news, is that you may have talented business users who want to explore more sophisticated business questions like, what is the relationship between these two variables? What is the forecast of these variables based on what we have today? What kind of patterns do I see in these variables? We're exposing those kinds of advanced analytic questions in the form of that Excel function that I have up above. And as Shawn mentioned earlier, what we are working on at Sigma is even more steps to make this more business user friendly, where rather than having to specify the Snowflake location of the UDF, we'll just be able to wrap this entire thing in a custom Sigma function called, for example, linear model. So with that, I'll pass on to another example. I think this is one of the most common examples that I see this need, which is live forecasting. So allowing a business user to look back in time and look at perhaps an order count by month. This is a classic Sigma exploration. We're always doing stuff like this where we're aggregating by a time variable and looking at an order count month by month. And this is great. It allows us to understand the past, and we can make educated inferences about the future, but we're lacking that kind of quantitative forecast that a lot of advanced statistics can give, but just till today has not been available in Sigma. So what I'm doing is I'm using the exact same methodology that I showed you with that linear model. Is I start with the month of order date, I get an order count. These are both calculated in Sigma, and then I just apply this order prediction. And what this will do is it'll take those two variables in, order count, month of order date, and it'll calculate a time series model based on my provided seasonality. And when I scroll down, we can get a sense of what that looks like. What we're able to do is observe the past and fit a forecast into the future of 3 years with a confidence interval to let me know what I would expect in December of 2025. And again, the ability to create these kinds of custom aggregations lets me take that data and say, what's the month that I'm going to have my highest monthly orders? What's my total for 2023? Looking at my forecast as confidence interval, what's the worst case scenario? And these are all really critical business questions that are going to help me set targets, help me make budgeting decisions that I can't do unless I have this kind of quantitative output. So enabling a business user to set a forecast and build a forecast on their own is going to be a key step in enabling that kind of forward-looking analytics. So I've shown you the linear regression example. I've shown you this forecasting example. I'll take another pause for questions here. Nate, are you getting anything in the chat?
No, I think we're all good. If anyone has questions about forecasting, time series analysis, feel free to throw it in. Otherwise, we can move on to the NLP.
Sure. This is another exploration that I've been kind of looking into. It's the same functionality. As we move from linear to time series to NLP, it's always going to be the same methodology, which is where I am able to put in data and run it through UDF, where I calculate sentiment and I just run it on the variable that I need. And on the back end, we're sending that request to Snowflake to run whatever statistical or analytical or data science method that I want. In this case, it's a sentiment model. And what this will do is assess the sentiment of whatever text I put in. So today is a beautiful day, gives me a 0.5994 positivity sentiment. Data limitations in Excel put me into a furious rage. That puts me at negative 0.6486. So that's going to be a negative sentiment. And I can add a new one on the fly here, where I say, we love our partners. And we'll be able to see, let me delete that extra row, that we love our partners passes us a 0.6696 positivity. And so we're graphing that down below. This is not something that we have seen a lot of our Sigma customers exploring, but I think really that's just because they didn't know that they could. So imagine applying this kind of technology to customer feedback, to product reviews, to maybe even transcript recordings from calls, to start doing some kind of triaging of what products need special attention, maybe what training needs to be done. There's a lot of things that we can do with our NLP tools and NLP integrations here as well. So definitely want to be saying, yes, we're happy to work with NLP use cases, and we love that the partners are, any partners that can bring those to us. But B, that this is a really flexible method. All that needs to happen to build anything, whether it's time series, NLP, or a linear regression, is the ability to code that model on the back end and then provide that as a UDF for your end users to use. So what we can see too is another example of this input sample, or excuse me, this input table where we can make stuff on the fly. But what we also have seen in our live forecasting is the ability to run it against existing tables. And so together, we want to be able to show that this is a UDF that can be used across existing warehouses and new data, and that there's going to be great applications between the two, depending on what fits the use case. But ultimately, this is something that's great for anywhere where you have a large data set and you want to be drilling into specific aggregations, anywhere where you want to be adding in that ad hoc data, or really anything in between. So with that, I will pause one last time for questions before I jump into what it looks like to actually code these out. I know that this is a technical audience, and so I want to be able to speak to the systems for getting these in place. But any questions on the Sigma side of things before I move on?
Yeah, we've got a question from Adam here. He's asking if everything that you're showing is currently available in Sigma.
Yeah, that's a really great question. Literally everything that I've done right now is something that any Sigma customer could do and could have done already. So we're using the existing technology to leverage UDFs, so pass-through functions. That's something that already exists in Sigma. And then Snowpark is something that just needs to be, Snowpark actually already runs in Snowflake instances. You just have to write the code to leverage it. So both of those functionalities already exist in every Sigma on Snowflake deployment. Any other questions?
Looks like we're all set. You can probably go ahead.
Awesome. All right, so what I'll do is leave the Sigma space and open up my Visual Studio Code. And, excuse me, this is my preferred editor, but really whatever code editor you want to use to integrate or to work in Snowpark is up to you. All Snowpark is, like if someone asks you like, where is Snowpark, where can I find it, how can I work with it? It's just a method for connecting to Snowflake and writing commands that will then run on Snowflake compute. So that's all that I'm doing here, is I'm loading some required packages to just work with the data locally. I'm authenticating into the space, or I'm authenticating into my Snowflake account. And then once I'm set up or authenticated, all the process involves is creating code that you define locally that will then run on Snowflake compute. So for example, the steps here, I set up some parameters so that this can be general use code. So where I'm going to store my models, what tables I'm going to run it on, and then what Sigma role needs to be able to use it. And then I create some training tables and testing tables to train the model on. That's going to be a key piece of creating a model. But then the meat of it is right here, where I define a stored procedure to train the model. So I take in my feature columns, I tell it what my target column needs to be, and then I say that it needs to save the model to my model name location. All I'm doing on my local environment is defining how Snowflake's going to run this operation, and then I register it, and then I send it, and then I send the command to execute. And that's what's going to create that saved model file that's available in the Snowflake instance. And then all that's left is creating a system to pass parameters in. So that's that score decision tree model full. Give it a nice name like customer loyalty model full, save it in the stage that I want. But ultimately, all the UDF is doing is creating a way to create scored data. So we see that I'm model predicting off my input data frame. So that's where I selected the zip code and the customer age. That's that data frame. I'm predicting off the model, and the model is that model that I defined in the previous stored procedure. So that's how we do that kind of governed basis, is the model gets defined by a stored procedure, saved to a location in Snowflake, and then the UDF just passes information in and out of that stored model. The model will never change while being run. That's the governed space. And then the ad hoc space is just removing a step because it's creating the model in the UDF itself. There's no kind of pre-trained, pre-saved model. It just creates a model every time. And you'll be able to, if you've worked in Python, you'll be able to recognize that this is actually very similar to if you were just working on a data frame yourself. So we're taking in a data frame, we're grabbing the values, and then we're fitting a model, and then we're getting the outputs of that model in the prediction error, the score, all that kind of stuff. So the two methods are only different in that in the governed state, we create a model that's immutable in the Snowflake instance, and in the ad hoc method, you kind of create the model every time the UDF is run. But this is the highest level run through that I could give. I know that I scrolled through a lot of code and kind of hard to ask coding questions over a GoToWebinar chat, but if there are any questions on this, I'd be happy to dive into whatever part folks are curious about.
Thank you, Fran. It looks like we have a question about how real time your insights here could be. So if you have streaming data into the source, how real time will the UDF function respond to that streaming data?
Yeah, that's a great question. The data has the same real time setup as it does in the rest of Sigma. And by that, I mean, everything that you see in Sigma is live to the Snowflake connection that it's reading from, or whatever warehouse you're reading from. So what you'll be able to see is exactly what lives in the Snowflake warehouse. If the Snowflake warehouse is up to the second live, the Sigma data can be up to the second live, and the UDF will be able to run at that same level of precision. So ultimately, the short answer to your question is it's as live as it is in Snowflake. Yeah, and I guess there's another element there that is worth pointing out, is that similar to how if you want regular Snowflake queries to run faster, you up your warehouse size. That's exactly the same methodology that we would apply here. So you would be able to actually, if the query times that we saw, which took a few seconds, if we wanted to get that even faster, you would have the same flexibility with your warehouse provisioning that you do for the rest of your queries. Any other questions,
folks? Are there any other questions? Fran, are you going to socialize these UDFs so that users here could grab them themselves and play around with this?
That is definitely my plan. So I'm already working on how I can expose these through a repository so that folks will have a getting started for the UDFs that I've made. Yeah, as you get started, sometimes there's a steep learning curve to understanding exactly how they need to be set up to work with Snowpark. So happy to provide what I've figured out that way as a starting place.
Excellent. Can we expect to see a quick start on this topic in the near future?
I would bet on it, yes.
All right, great. Stay tuned for that. I'll send an update when that happens.
Yep.
Are there any other questions about Fran's data science workbook here? Looks like Shanti is saying, asking if the Snowpark optimized warehouses are being leveraged. I think, Fran, you had answered that. Is that right?
They are not here, but they absolutely could be. So the Snowpark optimized warehouses, if you have for example, a Sigma workbook that is heavy on Snowpark calls, that would be a great opportunity to use the Snowpark optimized warehouse.
Wonderful. All right, looks like we're
Great.
all set.
Okay, so one last point before I open it to, I guess, general questions and some wrap-up thoughts is there is another avenue that Snowflake is kind of opening up to getting started with these kinds of advanced analytics. So for folks who, for whatever reason, are not able to write UDFs or don't have the time to invest into writing UDFs, there is the SQL ML private preview allows folks to actually work with Snowflake pre-provided models. So what I can do here is exit the dashboard that I was in, and I have a Snow ML dashboard here. And what happens in the Snow ML dashboard is the same kind of forecasting that I was able to achieve in my UDF, but it's just a much simpler method and much easier method to set up for Snowflake customers. So what's actually happening here is we have this Snow ML forecast or SQL ML forecast that is generating forecasts for whatever model you put in. And I've set up some SQL parameters so that we can kind of explore this, where I can change what value I want to forecast. So instead of forecasting order count, I want to forecast total revenue. That'll send that in as an updated parameter to my SQL code, and we'll be able to see how the pre-trained Snowflake SQL model would work. when I say pre-trained in this sense, I mean that I didn't even touch it. This is something that Snowflake manages for us. So this is the quote unquote easy button for working with forecasts. And I'll give y'all a sense of what that looks like. So when I hit edit here, we'll see that this SnowML forecast is coming from a data set that's built on SQL code. So let's view that. And in my worksheet here, we see that it's coming from custom SQL. So folks who are comfortable with building data sets from custom SQL will understand what this means, but it's basically the ability to bring in a table from the warehouse with some SQL flair to it. So when I hit edit this, you'll see that what we're doing is we're actually calling this app called the test forecasting app.snowml.forecast. And what this is able to do is just take in a date, take in a raw value to forecast, take in a forecast length, and then build out a forecast into the future. And it will dynamically create a new table from those inputs where it'll turn your input date into a time series, your input value into a Y value, and create these forecast values for as many periods into the future as you would like. So this is a way to kind of avoid writing the Python UDFs that I've been talking about so far. But the trade-off is that you do not have the flexibility of what kind of outputs that forecast model will have, how it was trained, that kind of thing. So this is what I would recommend is as a good getting started and maybe getting comfortable with forecast as a brand new way to work with time series data. And it's definitely a valuable out of the box feature as a private preview with Snowflake. So definitely wanted to speak to that. I think Shawn will provide some parting thoughts on this, but any questions on using the forecast here? Alrighty. Well, with no further questions on that, it might be a good opportunity to either hop back to general questions about the entire workflow that I've talked about here. So I can go back to my dashboard and take us to one of our forecasting models. But otherwise, happy to give folks some time, but also would love to hear if there are questions.
Fran, why don't we hop back to the deck and give folks some time to type in their questions and we can address them after.
Yeah, sounds good.
Cool. So all this great stuff that Fran has showed us is really just scratching the surface of the opportunity here. Snowflake has really revolutionized the ability to get these ML models deployed to a business in rapid speed with all of their Snowpark innovations. Primarily the ability to have your machine learning models live in the same context as your enterprise data. It plays to the general theme of breaking down data silos and providing a flexible interface for developers with all different languages to be able to work in that same context without having to move data and incur egress charges or anything like that. So it's a really beneficial platform to build a machine learning center of excellence on top of. And so we're really excited to really be the front end and bring all of this to the business. And so obviously we talked about the SQL ML functions. We're really excited. We'll actually be the launch partner with Snowflake on this new feature. And the private preview is currently available for any of our SI partners out there. Highly recommend getting into that private preview and doing a little bit of exploration the same way that Fran showed off. It's a really good way to get your feet wet and start down your analytics journey. But for most companies, that's eventually going to drive an interest in machine learning to the point where they'll actually want their data science team to maybe build out their own forecasting models or whatnot. And that's where we see Sigma custom functions coming into place. And so our framework for aliasing these UDFs is really going to be that bridge to bring ML to the business. And we'll be launching that at Snowflake Summit. So one of our sessions that we'll be running is actually a really great experience around bringing input tables, user-defined functions or Python user-defined functions that wrap that ML model and all of the other Sigma goodness into one cohesive story. So highly recommend coming by and seeing our theater session if you'll be in attendance at Snowflake Summit. With that, I think Nate's got some closing thoughts on the overall thing. But
yeah, thank you so much, Shawn. Thank you, Fran, for this amazing demo and the work that you put into this. It's pretty mind-blowing how the input tables and Snowpark work together to generate insights so fast and seamlessly. All right, so if we can go back to the deck, I'm going to close this out here. I just want to thank everyone again. This is our first webinar. I hope this was useful, and I just want to thank everyone for attending, and we'll see you around.